Hello and welcome to another video on Python for machine learning. In this video, we're going to learn about functions and the concept of functional programming. Okay, it's finally time to talk about functions, and this is where things get really interesting because up until now we have seen functions like print, like bool, and we have seen that these functions allow us to perform actions on our data types. But the true power of functions comes when we start creating our own functions. That's right, we're not limited to the functions that Python gives us. We're able to create our own functions and use them in our programs. So let's learn how to do that. So the way we define a function in Python is we say def, which stands for define, and it lets the Python interpreter know that we're going to define a function here. Now we got to give our function a name. It could be anything. In our case, it's say hello, and we put the brackets, a colon, and you see there's a little space here, the indentation. This actually means something in Python. It means that whatever you say after this space will belong to this particular function. So let's write our function here. Print hello. And okay. Now let's run this. You see, nothing happens. Why is that? Because we haven't called the function yet. To print something, we have to call this function. Now let's call this function, and you see I got out of that space, so we are not in that. We're going to call our function, and you see even before we call our function, it gives the function say hello, which we defined above, and there's this box in front of it. It means that it's stored as a function in the memory of Python. So let's just click on it, put the brackets, and run it now. Okay, we're done. We ran our function successfully. So let's see what happens if we try to run it without these brackets. Nothing happens because remember, in order for us to take an action, we have to let the interpreter know. So let's put these back, run it. Now, the reason functions are so powerful is because of the principle of DRY, DRY, which stands for do not repeat yourself. Functions are really useful when you have things that you want to do over and over. For example, let's say we had to write the print function every time we were coding. Wouldn't it be really difficult? Isn't it really helpful that we already got the print function, so all we got to do is type print and give the parameters. Now let's take another example. In this example, you see we have this picture, and we can say that it's storing the data of a picture. There's a list, and inside it there's multiple lists. So let's say what we got to do is we replace every one with a star. So how do we do that? First I'm going to write the code, and then I'm going to explain it. For So, okay, we got a nice little Christmas tree here. So what we did was, first we set for image in picture. It means that this variable image will iterate over this list. One by one, it will go over this big list. And for pixel in image, it will iterate over the contents of the image, means it will go over this list, this 0 0 0 1 and 0 0. Then we said if pixel, means if pixel is true, means there's 1 here, then print star, so it printed star, else print a space, and where it was 0 it printed a space. Now what is this end? Now the parameters of print has this end which by default is next line /n. So every time it will go to a next line, but we don't want that. We don't want it to go to a next line. We want this space there. And after this we print this space so that it goes to next line and iterates over this list, then this list, then this, and forms this Christmas tree. Now let's say we had to do, or we had to portray multiple Christmas trees. We can just copy this and paste and then run it. You see we got this double Christmas tree, but the thing is we use so much lines of code and we wouldn't go about copying it every time. So what we can do instead is we can define a function here. So the way we do this, we said def Christmas tree, put these brackets, and then we just put all this inside this function, and so all this is inside this function, and when we run this nothing happens. Again, we haven't called the function yet, so let's call the function Christmas tree and we call it, and you see it printed the Christmas tree. Now we can just copy and paste this and say it again and again, and we got 3 Christmas trees, and all it took was to define a function and only these much lines in the memory. So it's memory efficient and easy to call. So that's the power of functions. Functions allow us to keep our code dry. We don't have to repeat ourselves, and we can reuse the things that our machines can do over and over. Now let's move on to something called functional programming. So what is functional programming? It's all about separation of concerns. It's all about packaging a code into separate chunks so that everything's well organized in each part of our code. So when we say separation of concerns, what do I mean? It means that each part is concerned with one thing that it's good at. Now there is no correct definition for what is and what isn't functional and is not functional programming. But it's basically the idea of making our code clean and understandable and easy to extend. So it's better for others to come and extend our code. It's easier to maintain and it keeps our code dry. So you don't have to repeat yourself and your code becomes memory efficient. Because we are not storing information all over the place, we are just going to store that information in a function and we can call it anytime. Now, when it comes to functional programming, there's one very important pillar, and it's called pure functions. So, we're going to learn about pure functions and explore that a little bit. So, what is a pure function? Well, a pure function looks like this. We have a box inside which, let's say, we have a simple function and we give it this input, this list of 1, 2, 3. It goes inside the box. The function performs an action on it, something very simple, and we get this output. What we want is every time we give this input to this function, we want that same output. Now, a pure function has two rules. The first one is given the same input, it will always return the same output. So, if I run this function a million times with the same input, it should result in the same output. And the second point is this idea of a function should not produce any side effects. What are side effects? Side effects are the things that a function does that affect the outside world. For example, if I was to print something inside of this function, it affects the outside world, right? Because I'm printing something onto the screen and screen is the outside world. For example, if this function was touching a variable that lived outside of this function scope, that's also a side effect. Now, let's look at a code to understand this concept a little better. So let's define a simple function here. We say define multiply by 2, and what we want this function to do is we want this function to take a list as an argument and multiply each of the elements in that list by 2. So the way we do that is we say for item in list, and this will iterate over each of the items in the list, and we want that each of the items in that list is multiplied by 2. So we also need a new list, an empty list, to add all of the multiplied by 2 items to that list. So let's define a new list, and this is an empty list. Then we say new list dot append and item multiplied by 2. So what this says is new list dot append item multiplied by 2. It will multiply each of the item in that list by 2, and then it will add those items to this new list. Now let's call this function, and the way we do that is again multiply multi, and we have already saved it in the memory because it was defined, so it's saved in the memory. And then we pass on a list as an argument, so 1 2 3, a simple list of 1 2 3. And if we run this, we get nothing because we have printed nothing. So let's print it. Again it says none. So why do we get a none? It's because this function, it doesn't return anything. There's no return statement, it's not returning anything. So we want to give it a return statement, and what do we want to return? We want to return this new list. So let's run it now. Okay, we got our answer. We gave 1 2 3, and each item was multiplied, and we get a list of 2 4 6. Now, is this function a pure function? Let's review the conditions again. Given the same input, it will always return the same output. So the first condition says, given the same input, it will always return the same output. Now, if we give this function this same input like a million times, will it return this same output 246? Yes, it will. So the first condition is satisfied. Now the second condition, it does not produce any side effects to the outside world. Does this function produce any side effects to the outside world, or does this function interact at all with the outside world? Well, no, it doesn't have any element that belongs to the outside world. Everything is within the scope of this function. So both of the conditions are satisfied, and we can say that this function is a pure function. Now moving on, what if I remove this print statement here and this bracket here, and instead of return here, I say print let's run it now. We get the same output, but the thing is, this function now interacts with the outside world. You see, there's a print statement here. Print function interacts with the outside world. This screen is the outside world, and print is interacting with that, and it's inside the function. So this is now not a pure function. Now instead of this, let's say, instead of the new list being here, if I remove this, I'll copy this and remove it, and then I'll add it here. So if I run this now, it's still giving the same output. But the thing is, this again interacts with the outside world. New list is now outside of the world of this function. The world or the scope of this function is within this space you see, and the scope of this function is here. The world of this function is here, and this new list now belongs to outside of the world of this function, outside of the scope of this function. So this function again interacts with the outside world, so it's not a pure function. And what can happen is, let's say if a new programmer comes and let's say changes this new list to a string, and if I run this now, I get an error because the new list is now changed to a string. So you see, the thing about pure functions is it protects from buggy code. If you have a lot of pure functions, then you'll have a less buggy code. Now, practically, all your functions can't be pure functions. At some point, your functions got to interact with the outside world. But it's good practice to make most of your functions pure, most as you can, so that you have less buggy code. Now, the thing is, let's say you have a bug in your code. You don't have to review the pure functions because most likely that bug is from a non-pure function. So that's the power of pure function, and that was all about pure functions.